The fun continues. So last video, in video 5, we went over the gastric cells and glands and what they secrete. It is helpful to have that with you as you go through this video, to have your notes, especially if you've done a drawing like I've asked you to, where you have the cells in a box and then coming off that box is what it secretes and what important that is. So the gastric phases are the different phases of the stomach tied in with the small intestine as you eat. All right, so the first phase is called the cephalic phase. So think of the word cephalic, we're talking about the brain. So again, this tie-in between the brain and the digestive system is very strong. This occurs even before the food enters the stomach. It occurs at the thought of food or the smell of food. And you can see this with dogs. You know, you put a hamburger in front of them or near them and they smell it and they start to salivate. You know, your stomach's also preparing for food in the sense of smell or even the thought of eating beforehand. When I was at VU a long time ago, I had a golden retriever and it was finals week and we were doing study groups, and so I brought her in just for the heck of it. And she was just sitting there, and so some students came in for a review session, and one of them didn't really like dogs, and she brought a hamburger in with her, and the dog was very good. So my students sat down with their hamburger, and of course my dog, her name was Dickens, my dog went over and just sat like very nicely 5 feet from her and just stared at her. And so the student was like, well, why is your dog staring at me? I'm like, well, it's not really about you, it's about the hamburger that you have in your hand. So the smell of that hamburger, you know, got the juices going, as you can commonly say. Same thing with your stomach. So in the presence of food, the sight or the thought of it, your stomach is going to respond to that. And again, that signal initially is going to come from your brain, because your brain is what's interpreting the smell or what's going to happen in the future if there's food in your future. So that is the cephalic phase. And again, the stimulation comes from the hypothalamus. It happens through the vagus nerve. And again, just another review, the vagus nerve is the primary nerve of the parasympathetic nervous system. Remember, the digestive system is under the control of the parasympathetic nervous system. So that is the cephalic phase, before the food has even entered the stomach. Then we get into the gastric phase, and this is the phase where there's going to be stretching of the stomach because you have consumed food, consumed food. And it's going to be controlled primarily by the proteins that you are consuming. What will happen is we'll get gastrin secreted by G cells. If you go back and look at your notes, the enteroendocrine glands, one of the things they secrete is gastrin, and that comes from cells called G cells. Again, you should see that in your notes from the last video. I'm going to show it to you this way, and then I will show it to you in a format that I think is a little bit easier. The gastrin is going to increase hydrochloric acid production. Remember, what's going to happen is that's going to cause the blood to actively transport the hydrogen into the stomach lining. So this is in the presence of food, specifically proteins. The presence of food or proteins in the stomach, you get a stretching of the stomach. You get the increase in gastrin, causes increased hydrochloric acid production. That extra hydrochloric acid is going to convert pepsinogen into pepsin. Pepsinogen being the inactive form of the enzyme and pepsin being the active form. And then the pepsin is going to start to chemically break down the proteins that you've consumed, the proteins that exist in the chyme that is in the stomach. Here's another way of looking at it. Again, I highly recommend that you put it into a format that you can understand. So we get, when proteins enter the stomach, you get an increase in pH. That's going to cause the release of gastrin. Gastrin's going to cause an increase in hydrochloric acid production from the parietal cells. Plus you get this hydrogen actively transported. So go back again to your notes on the different cell types and what they secrete. So when you get proteins in the stomach, you get an increase in pH. Going away from homeostasis, you're going to get gastrin secretion from the G cells in the stomach lining. That's going to cause an increase in hydrochloric acid production from the parietal cells. The hydrochloric acid is going to convert the inactive form of pepsinogen, which is inactive, which comes from chief cells, into pepsin, which is the active enzyme, which will start to chemically digest proteins. Pepsin starts the chemical digestion of proteins, which lowers the pH. This inhibits the release of gastrin, and again, you're turning it off. So by changes in pH caused by the presence of proteins in the stomach, we then increase gastrin, which increases hydrochloric acid production. That hydrochloric acid converts an inactive form of the enzyme into an active form. We start to chemically digest the proteins, which changes the pH and inhibits the release of gastrin. That is the gastric phase of the stomach. So again, you might put this in a step-by-step like this. You might want to redraw it, put each in a box, going through what happens during the gastric phase of the stomach. The third phase, so once we've done this, now your stomach is churning and mixing. It's doing some chemical digestion of proteins. But now what's going to happen is we're going to enter in small amounts, in spurts, small amount of this chyme is going to enter into the small intestine, where most of the chemical digestion and most of the absorption is going to take place. So we've churned it, mixed it, we've done some chemical digestion of proteins. Now, what's in the stomach is now going to enter the small intestine. So in the intestinal phase of the stomach, two things are going to happen. Actually three things. One, we're going to get into the small intestine what we need to get in order to do chemical digestion. We're going to make sure that chyme coming from the stomach is not too acidic, because it's going to be acidic because it just came from the stomach. So we're going to have to try to neutralize that. And this sounds strange, we're going to have to kind of temporarily turn the stomach off. So we want small amounts of food, of the chyme from the stomach, to go into the small intestine. We want that small amount to start to be chemically digested and absorbed. We've got to make sure it's neutralized. And we want to give that spurt or squirt a little bit of time to start heading down the small intestine before the stomach would then squirt another little bit of that chyme into the small intestine. Okay. So this is the intestinal phase within the stomach. So chyme's going to enter the duodenum, which you know is the first part of the small intestine. Again, it's going to go in small spurts. So think about a little squirt, a squirt bottle. You squirt a little bit from the stomach into the small intestine. Allow that to start the digestion process before you would then squirt another one. Let it start to digest, then squirt another one. So we just don't want the stomach, okay, the pyloric sphincter between the stomach and the small intestine to just open and all of it from the stomach go into the small intestine. The digestion would not be very efficient. Okay, it would not be very efficient. So we're going to get secretion, little secretions from the small intestine, okay, including cholecystokinin. So the chyme a little bit squirts in the small intestine. We get the secretion of cholecystokinin. These two things, okay, we're now going to get some of the juices from the pancreas, the enzymes from the pancreas. Remember I told you early on, there's two accessory organs in digestion, the pancreas and the liver. The gallbladder is part of the liver. Okay. These two accessory organs, the food does not go through them, but what they do is they contribute chemicals, hormones, enzymes that are going to help with the chemical digestion and absorption of the nutrients in the small intestine. I told you that you can live without a stomach. You cannot live without a small intestine. The small intestine is where most of the chemical digestion and most of the absorption is going to take place. If you take even a small segment of the small intestine out, you are not able to chemically digest or absorb nutrients. You just can't survive. Okay. So the goal of the small intestine, and we'll talk about this in the next video, is to provide a surface area so chemical digestion and absorption can take place. Okay. All right, so when this small amount of chyme enters the small intestine, cholecystokinin is going to cause the pancreas to secrete enzymes into the small intestine. These enzymes are going to do most of the chemical digestion of the nutrients in that chyme. It's also going to cause the gallbladder to secrete bile into the small intestine. The bile is going to help emulsify the fat. Emulsification with this bile is another example of mechanical digestion. It's going to break the fat into a big blob into small blobs so that the enzymes can break it down. So when we take a small amount of chyme from the stomach into the small intestine, we get the secretion of cholecystokinin. It activates the pancreas to secrete the enzymes that are going to break the nutrients down, and it stimulates the gallbladder to secrete bile, which is going to help break down the fat. Okay. The second thing that's going to happen as this chyme goes into the small intestine is we're going to get secretin. Okay. Secretin's going to help neutralize that chyme. Remember, it's coming from the stomach, which is very acidic. So we need to neutralize it for several reasons. One, so the enzymes work better on it and are able to break it down, chemically digest the way that they're supposed to. But also, if this chyme is very acidic, it can actually eat away at the lining of the small intestine. And you can actually get what's called a duodenal ulcer, which is similar to what we talked about in the esophagus, but on the other end of the stomach. And the last thing that's going to happen, we're going to get what's called the enterogastric reflex. Like I said earlier, we want a small spurt or squirt of chyme to go into the small intestine. We want it to start its trip down the small intestine where it's getting chemically digested and absorbed into the bloodstream. The enterogastric reflex, what it does is after that small squirt goes into the small intestine, the stomach kind of shuts down, stops churning as much. After a time period, it then will activate again, send another squirt in. Enterogastric reflex will kind of shut it down, turns on again later, sends another squirt in, and so on. Again, what this does is this gives the small intestine a easier time of chemically breaking down, chemically digesting, and absorbing the nutrients. It works much more efficiently than if you just sent everything from your stomach right into the small intestine all at the same time. Okay? So again, cholecystokinin activates the pancreas, which is going to help with chemical digestion, and the gallbladder, which is going to help with mechanical digestion of fat. Secretin is going to neutralize that chyme to protect the small intestine, to allow the enzymes to work better, and then the enterogastric reflex will shut the stomach down a little bit, wait a little while, and then another one will come in. Okay, that's the intestinal phase of the stomach. All right, real quick overview. Cephalic phase in the stomach happens before you even consume the food. You get changes stimulated by the vagus nerve, which is part of the parasympathetic nervous system. The gastric phase is what happens when the chyme is in the stomach. You get the start of the chemical breakdown of proteins. Then the intestinal phase is as the chyme moves into the intestines, things are done to increase the ability to chemically break down the chyme, to neutralize the chyme, and to make sure that it goes in small squirts instead of one big clump, okay, to increase the efficiency of the small intestine to break down and absorb the nutrients. Okay, so stomach overview. It mixes and churns. You get some digestion of proteins, not a lot. With alcohol and aspirin, you will absorb them into the bloodstream. That's why when consuming alcohol, they tell you to eat first, so it decreases how quickly the alcohol will absorb into your bloodstream. Liquids will stay in your stomach for a shorter amount of time than solid foods. That's why when you're just drinking stuff, you tend not to feel as full. Meals that are higher in fat will also stay longer. That's why having some fat in your diet is actually good for you, because it makes you feel full. If there's not a lot of fat in your diet, then you tend to be more hungry, especially if there's a lot of carbohydrates. Okay. All right, so what is vomiting? Some of this may make you feel like vomiting as you listen to this. Vomiting can be very psychological. It can also be very physical, but it can also be psychological. So there are 2 phases to vomiting. The sound of this, if you can hear it well, can actually make you want to vomit. So this is when your abdominal muscles start to contract in a coordinated fashion, but nothing may come out. So you're just kind of gagging, okay? You're kind of gagging. The expulsive phase is when your diaphragm and abdominal muscles undergo a massive prolonged contraction, putting pressure on the stomach, and it kind of, the esophagus relaxes, the sphincters open, and boom, everything's coming out. Okay, kind of like taking the plug off a fire hydrant. Why does this happen? Okay, why do you vomit? We don't know exact reasons why in some cases. Like for some of you, just listening to this makes you want to vomit. That is, again, is the psychological aspects of it. Okay. So when someone has something toxic in their body wants to get rid of it. When someone starts getting close to alcohol poisoning, they may start to vomit. The reason for that is their body is thinking, you've put this chemical in me that is toxic. I need to get it out. Okay. Someone is getting chemotherapy. We talked about with cancer. They're going to want to feel, they have this chemical. It's a toxic chemical in their body. Their body wants to get it out. Okay. And that's one reason that a person may want to vomit. Morning sickness in women, you will hear about. It can happen all day long, but a lot of times it happens in the morning. They wake up, they're nauseous, they smell food, it makes them want to throw up. They don't know exactly why this is it. They think it's the body's way of protecting the fetus. So by keeping the woman from wanting to eat things, they keep her from eating something toxic, or she's trying to get something toxic out of her body that the body perceives as possibly hurting the fetus. A lot of times this isn't true. Some morning sickness can be very deadly for the baby and the mother, because she just can't get anything down and she keeps throwing up. So for some mothers, it can last the whole pregnancy, and they really need to stay sometimes hospitalized to make sure they're getting an IV and so on, to make sure they're not getting dehydrated and make sure that they are consuming nutrients. Motion sickness. So, some people get motion sickness in a car. A lot of times what motion sickness is caused by, when your eyes and your vestibular system that we talked about when we talked about hearing, your semicircular canals, if your eyes are perceiving something different than what your vestibular system is sending, so your eyes say we're moving, but your ears say we're not, that can make a person motion sickness. Sometimes that can cause vomiting. Why exactly? They don't know. It could be that the body perceives a high stress, and in a high stress situation, you want to vomit. So if you've ever, the last time I've really vomited is when I had a kidney stone. And so if you've never had a kidney stone, they're incredibly painful. So I just remember thinking, oh my God, I didn't know what it was. And it was very, very painful. And when I finally knew I had to go to the hospital is when I just started getting really nauseous and just started throwing up. And I was like, okay, that's the signal. That's your body's signal that something is really wrong. So a lot of times that will tell people, okay, something is really wrong. I'm not being a wimp. I need to go to the hospital. So again, it tends to be a high stress kind of thing that happens. Maybe it's your body's way of saying, hey, stupid, go to the hospital, get something done because something's wrong. Okay. All right. So that's the basics on nausea and vomiting. This you may not find amusing, but I'm just going to share it with you anyways. It's not really that funny, but I just thought I'd keep it in here. So this is the end of the stomach. We've kind of started the introduction into the small intestine in this video, but we will continue the small intestine in the next video. So again, make sure you can answer the objective questions based on what you've learned in this video. And we will move on.